So now we're going to sort of get into the park itself. We're going to sort of start at the south end and move north. But one thing I wanted to point out on this figure right now is there are two geographies. One sits here in the western part of the park, and there's some high relief there. But in general, it's a relatively muted landscape that's not cut by any deep, deep valleys. In a sense, friendly alpine area. It's essentially, it's a rolling upland with a couple of high peaks on it. Now that's in real contrast to what lies to the east. You get into sort of the high peaks, the granite peaks of Castle Towers and the Sphinx and Deception Mountain, Mamquam Peak. These are really rugged landscapes cut by very, very deep valleys, the upper drainages of the pit. You know, I'd venture to say that 98% of the people traffic to Garibaldi is in this area, and 2% back in here. That's just tough ground. Climbers go there, but not many mountaineers, you know, really get into that back country. I mean, there's a question for us. Why those two different worlds in the park? When you head up the Elfin Lakes Trail, that really stands out in quite an extraordinary way. You're walking on this very gentle ridge system, yet you look, that's Mamquam Mountain in the background, at really rugged country. And the question is, what's going on? Why is one so gentle and the other so rugged? Likewise, Garibaldi is famous for its meadows. You know, here it's the blueberry bushes in fall color, but elsewhere it's the alpine meadows. Both subdued landscape and those sort of rich meadows relate to geology. And the answer here on Paul Ridge is that the ridge is underlain by very soft volcanic rocks that weather very quickly. No climber is going to spend any time here because there's not much to climb. It's all falling apart too fast. But that falling apart too fast makes for wonderfully rich soils, at least in the alpine reference frame, wonderfully rich soils. And you can see the reddish cast to them. That's sort of the iron breaking out of the volcanic material. And it tells you something about how fast things are breaking down. And those just make good soils grow good flowers and good shrubs. There's a second part to that story. There's a second rock type that is relatively limited in the Coast Range, but quite abundant in Garibaldi Park, that also creates the subdued landscape, and they're sedimentary rocks. These are ancient seafloor beds. Some of them are exposed right at the ranger station at Elfin Lakes, and this outcrop, if you sort of pause and look down at it, you'll see that in fact it's made up of fragments, but they're not loose fragments. They're actually embedded in the rock, they're part of the rock. And this is essentially a seafloor rubble pile, a geologist called a conglomerate, 100 million year old, that happens to underlay this part of the ridge, has been smoothed by glaciers, but is soft enough that it really creates a relatively subdued landscape because it erodes easily. So I don't have too many of these diagrams, so don't worry. But this is an attempt to just, in simple terms, explain why. Why we have a western part of Garibaldi, which has the subdued landscape, and an eastern part of Garibaldi, which is completely rugged. And the answer lies in its geology. This is a cross-section from west to east, very schematic. But you can see that there's this gentle upland landscape. You know, Garibaldi Lake is sort of at a boundary zone. And then east of Garibaldi Lake, you get into this big ridge system of granite peaks. Those granite peaks, that's essentially the only place in Garibaldi where the granite's out. And so over here, instead of granite, what we've got are younger rocks that have been deposited on old erosion surfaces on the granite. And so the granite is overlain by these ancient sedimentary rocks. Sometime 100 million years ago, the granites were beveled flat. These seafloor layers were laid down on it. And then that was eroded. And much, much later, almost 100 million years later, we have volcanoes popping out and being deposited on top of this older sedimentary rock. And so those are really the three players that I'll be talking about: granite, sedimentary rocks, and volcanic rocks. And just so that we've got a better frame for exactly what geographies those relate to, the granites, You know, that's Castle Towers, Guard Mountain, Sphinx, Mamquam Mountain. That's these big high peaks. The sedimentary rock ridges, these muted landscapes, Panorama Ridge, Gentian Ridge to the north, Elfin Lake, that's what underlies that gentle landscape. And then volcanic rocks create gentle landscapes, particularly where there are lava flows. And there are three big lava flow systems in the park. One is Ring Creek, we'll talk about it first. One is the barrier, and it's got a sister lava flow that you don't see that comes down Calton Creek, but it's a second big lava flow. And the third is Kelm Creek. You don't really even notice that, but if you walk up from Checkman's Lake, the whole time you're walking on sort of a lava flow. It's being, you know, overridden by glaciers, and there's a big forest on it, so it's not obvious the way the younger ones are, but it's still lava. And one of the things about lava is that it's a liquid. It always goes to the low points, and it has filled in some of the valleys. So Helm Creek itself, which is a pretty flat, broad valley, is in fact flat and broad because there are two lava flows that have filled up, I'm not sure how much valley, but have essentially filled in what was a much deeper valley and created a much sort of flatter, subdued landscape. The volcanoes themselves that build themselves up, I mean, volcanoes are odd mountains. Every other type of mountain is essentially old rock, pressure treated at depth, brought to surface, and then carved by erosion into the sculpted shape we call a mountain. Volcanoes work differently. They actually build themselves, but because they build themselves, they're not pressure treated. They never formed at great temperatures and pressures, and so they're essentially really poorly built. And in being really poorly built, they fall apart fast. And so a volcano that does look like a volcano, you can almost guarantee looks like a volcano because it's still active, because it's still dumping stuff out on its slopes and building and offsetting the forces of erosion. So most of our volcanoes in Garibaldi are sort of in various states of erosion. Black Dust, the most eroded. Mount Garibaldi, half of it's gone. Table's in pretty good shape. Cinder Cone, Mount Price, and Opal Cone are the most conical mountains. If you look at and go, sort of looks like a volcano. You'd be right. Garibaldi, as I said, is not just Mount Garibaldi. It's not just one big volcano. In fact, it's a whole series of small volcanoes. And that really creates its magic and its intrigue. And so we're going to start down here and look at these volcanoes, and then we'll move north.